Hi, in this video we'll be talking about Kafka, which is a very popular event streaming platform. This was developed at LinkedIn as a data feed for all real-time data. Now, what's an event streaming platform? An event streaming platform consists or provides ways for the developers to pass events. It allows for ways to store those events, and it also allows for ways in which you can process these events, as we'll see later. So, as a requirement for a large tech company and or any large process, there needs to be some specific goals for an event streaming platform. And in case of Kafka, they were that high throughput was required, which is needed to support high volume event streams. It also needs to deal gracefully with large data backlogs, because sometimes your consumers might not be able to process data in the fashion or in the speed at which the data is incoming. So, which means that data backlogs are very common in production process, and it also needs to handle low latency delivery, because that's the way in which you can pass a lot of events of small size, and it can act as a message queue in certain manner. Now, this is designed to process data in a distributed and partitioned manner, and so some of the key characteristics of Kafka which makes it different and is worth noting is that it relies heavily on persistence. While most of the other tools that deliver or perform similar that provides a solution for similar kind of scenarios rely heavily on the random access memory, Kafka relies heavily on persistence because of two primary reasons. Number one is that in certain cases, if you are accessing the disk sequentially, it is much faster than performing a random memory access. And number two is that when Kafka was developed, Kafka is written in Java, and if you are familiar with Java, there is a decent amount of memory overload in storing objects in memory. Plus, when garbage collection happens in Java, that's typically a very slow process and is known to bring the entire process to a halt at times in order for the garbage collection to happen. So these were a very undesirable properties, which is why Kafka went ahead and makes use of the file system in a very judicious manner. The other thing is about constant time suffixes. So if for example you look at again other systems, most systems use B trees in order to index and store the data. And if you look at B trees, they have the asymptotic complexity of operations in B trees is O log n, which is usually considered a constant time. But if you have disk operations involved in that, it doesn't become constant, like it keeps on increasing. So what Kafka does is that it has a persistent queue, and this persistent queue essentially means that so what happens is that every time there's a message that is written in Kafka, it goes in a write ahead log. So it's think of it as a file system, as a file in the file system that is being written every time there's a message that comes into picture. And what makes this happen is that every write is an O1 operation, which is a constant time, and writes and reads do not interfere with each other, and it provides the kind of scalability that you would need from a production grade event streaming or messaging system. The other parts about efficiency in Kafka is related to batching and byte copying. So what batching means is that if you look at I/O and network overloads, a lot of that happens if you are passing a large amount of small messages, smaller size messages. So what Kafka does is that it batches some of these messages and sends that batch of messages across the network or across the file system, so that the I/O is optimized. The other crucial thing to note is that These messages are often stored in represented in certain schema or passed in a certain serialized manner. So every time the message is received by the consumer, the message needs to be deserialized as well. Now, in some other systems, what happens is that you have to pass the schema of the message along with the message itself. But what Kafka does is that it separates it all out. So the schema is stored centrally in something called as a schema registry, wherein all the schemas are stored, and every time a message needs to be decoded, it reads the schema from schema registry, and it uses that to decode the message. So this essentially ensures that your message really contains only that data that the producer or the consumer is really interested in, and any schema related operations can be decoupled from the actual message transmission itself. So using these design principles, Kafka has been able to send trillions of messages per second, that kind of a throughput we are looking at. And it's a very popular, very widely used event streaming platform across most of the teams and most of the companies. So how does it happen exactly? So in Kafka, what we call is a topic. So think of topic as similar to queues, but the topics are partitioned. So what happens is on the left hand side you can see a topic with the first partition, and the number 0, 1, 2, 3 are the messages that are produced by the producer. So as you can see from this picture, every time the producer produces a message, it is appended to the file that is used as the buffer for the partition. So number 12 and number 13 and so on will be appended on the right hand side of this particular diagram. And in case of Kafka, as we have seen with other platforms as well, there are consumers that consume from these messages. Now there are certain consumer groups as well, as we have seen. So every consumer group maintains their offset of offset per partition as to where they have read last. So there can be two different consumer groups, A and B. So in this case, A has only read till the 6th message, and consumer group B has read till the 9th message. So the producer can independently keep on producing these messages, and different consumer groups can act on these messages depending on where they left off. Now, similar to acknowledgement in RabbitMQ, Kafka also has an acknowledgement wherein if a consumer consumes the message, they can send an acknowledgement saying that yes, the message has been consumed successfully, and it will increase the offset. If this acknowledgement is not set, then the offset remains the same, and every time you start that particular consumer group, it will start from the offset that is last known to be there. So as you can see on the right hand side diagram, the partitions help scale the Kafka cluster very easily, because if you have multiple partitions, you can have multiple servers, and that makes up the Kafka cluster, in which every time a message is sent, it lands onto a specific partition on that topic, and then these partitions are consumed by different consumer groups depending on how they want to act on it. So that's mostly the crux of what is to be there in Kafka. Now there are libraries in pretty much every language in which you can create producers and consumers in Kafka, and Kafka has there are a lot of data processing systems that support Kafka, and it's just very easy to interact with Kafka or use it as event streaming platform in your system that you are building.